CSIR problem. You will understand why it is a CSIR problem. A wave packet in a medium is constructed with a superposition of waves of frequency omega around omega naught. That's a general frequency, that is 100. Omega naught is equal to 100 and the corresponding wavelength is 10. And here is a table given omega and k. Now what you yes
sorry
yes
to
yes
disturb you. Sir, it is also done. You gave it as a.
okay please wait let me complete this. Yeah, there is an easy method, that's why I am taking it once again. So Vp, we need Vp by or Vg by Vp. Now let us first write Vp. What is Vp? Vp will be is equal to omega by k, and you can write omega naught by k naught. Now here you need not worry about anything because either of the value you can take. Here you can write omega naught as 100 and k naught as 10. So omega naught is 100 and k naught 10. So your Vp is 10. Okay. Now this is the first part of the question, that is finding the Vp. Now what is Vg? Vg is equal to d omega by dk. Now how will you find this d omega by dk? This we can again write it as delta omega by delta k. Now such that this delta represent the small change in omega, right? The delta represent the small change in omega. Now when I am moving from for example, let us take any of the two values which can be easily done. Okay, so this is one value, this is another value, this is one value, and this is the another value. Now delta omega I am taking it as 121 minus 81 divided by 11 minus 9, so that's equal to 40 divided by 2, that's equal to 20. Now we need Vg divided by Vp, that's equal to Vg by Vp. Vg we got it as 20, Vp as 10, so you got it 2. Okay, so Vg is equal to 2 times Vp. Now if you go like this, it is a bit different. You may have to do trial and error by using the maximum, the better, any of the points you can use, but still it will be a you may have to deal with the points, you may have to deal with the fractions. Okay, so now in this question I can immediately write here, see it is 981, 9.5, 90.25, 10 and 100. So here I can write omega is equal to k square, right? Omega is equal to k square because it's a square of the number 111 and 121. So what I need is d omega by dk. So d omega by dk is nothing but 2k. So once I know this k is equal to 10 or the value that we get, so Vg by Vp, or you write Vp is equal to omega by k, right? What is omega? Omega is nothing but k square, so k square by k is nothing but k. Now what is Vg? Vg equal to d omega by dk, which is equal to nothing but 2k. So what is Vg by Vp? 2k by k, it's 2. So it's a very simpler way of doing things. So that's why I told you there are two methods. Two methods means the same thing but it written in two different forms. In this question, in a deep water, phase velocity of the water waves is given by Vp is equal to under root g divided by 2 pi into lambda. Now whatever is constant we can write it in the beginning, g divided by 2 pi into root lambda. This is given as Vp. Now what is Vg? Vg is equal to Vp minus lambda dVp by d lambda. See, all formula you must remember. So that is equal to Vp minus lambda times dVp by d lambda. Now this we have to differentiate, dVp divided by d lambda. See, the constant remains as it is, under root g divided by 2 pi root of lambda 1 by 2 root lambda, right? So let me write that here, dVp, this is p, lambda into under root g divided by 2 pi into 1 divided by 2 root lambda. So what is Vp? Vp you just substitute here, under root g divided by 2 pi into root lambda minus this lambda, root lambda, and this lambda will can be reduced, that is the root of lambda into root of g divided by 2 pi into 1 by 2. So you can take all these terms common. So root of g lambda divided by 2 pi into 1 minus only 1/2 remains, so half. So half into root of g lambda by 2 pi. Now if you want, you can bring this 2 to the inside the root according to the options given. Okay, according to the options given you can modify. Do this. See here, we know this V, this is new, this is new, okay, frequency. The frequency of the wave is given to you. Now we are asked to find out the group velocity, right? So Vg is equal to d omega by dk. Now let us first write omega. What is omega? Omega is equal to 2 pi nu. So d omega will be equal to 2 pi d nu. And what is k? K equal to 2 pi by lambda, and dk is equal to minus 2 pi by lambda square by d lambda. Up to here this is fine. So now we need d omega by dk. We have d omega dk. So d omega by dk is equal to 2 pi d nu divided by minus 2 pi by lambda squared into d lambda. This lambda you can put it in the numerator, and these 2 pi and 2 pi you can get cancelled. So minus 1 divided by lambda square d nu by d lambda. Wait, this lambda will come here. This we have done it in our first class, but still, minus lambda square d nu divided by d lambda. That's equal to Vg. This is the another form of group velocity in terms of wavelength. So now the question is under root g divided by 2 pi into 1 by root lambda, or this if you want to write it as g divided by 2 pi lambda to the power minus 1 by 2. This would be better. Now nu is given. Now Vg is equal to minus lambda square. Now we need d nu by d lambda. The constant you can write as it is g divided by 2 pi into minus 1 by 2 lambda to the power minus 3 by 2. Now this is lambda to the power 2, so this is lambda to the power 4 by 2, that is lambda to the power 2 into lambda to the power minus 3 by 2. Just add, you will get lambda to the power 1 by 2. So Bg is equal to minus and minus get cancelled, so it's 1 by 2 g divided by 2 pi lambda to the power 1 by 2. So Vg proportional to lambda to the power 1 by 2. See, the option is 1 by 2. Okay, this is very similar to the previous question, very similar. So this V, we will just this frequency nu we will write it as under root 2 pi t. T is a some constant, we don't have to worry about that, by 8 into 1 by or we will write it as lambda to the power minus 3 by 2, lambda to the power minus 3 by 2. So this is our frequency nu. Now the same formula, that is Vg is equal to minus lambda square d nu divided by d lambda. Now that's equal to minus lambda square d nu by d lambda. We will write the constant as it is 2 pi t by 8. This is lambda to the power minus 5 by 2, because 1 you have to reduce. D by dx of x to the power n is equal to n x to the power n minus 1, and here you will get minus 3 by 2, lambda to the power minus 1 5 by 2. Okay, so that's it. So that's equal to minus 3 by 2, all the constant. With this minus I will write plus under root 2 pi t by 8 into, this is by 2, right? So here I have to make it 2, so lambda power 4 by 2 into lambda power minus 5 by 2. Now 4 by 2, 4 minus 5, that is minus 1, so that is lambda power minus 1 by 2. So Vg is proportional to lambda power minus 1 by 2. See, here I need the dimension of t. Okay, so frequency I know it's 1 by second, so 1 by second, and here 2 pi is a constant, I need not worry. So t divided by lambda is the dimension of length, so I can write meter cube. Now as it is, if I write, it will be very difficult for me to convert, so I will squaring on the both sides. Okay, now 1 by second square is equal to t divided by meter cube, and t is nothing but meter cube per second square. T, dimension of t is meter cube per second square. Now in the form of Vg in the question we have got Vg is equal to some what is it, yeah, some constant which is dimensionless constant into under root pi t divided by lambda, right? Because lambda to the power minus 1 by 2 pi t divided by lambda, or if you want to write the answer as it is, you can go to we have written as 3 by 2 root of 2 pi t divided by 8 times lambda to the power minus 1 by 2. So this is what we know. Okay, now this 3 by 2 we can forget, this 2 pi forget, t also 8 also you can forget. So this is of the form t divided by some constant k into t divided by lambda. Now what is t formula? That is meter cube per second square. So meter cube per second square divided by lambda. Okay, so divided by meter under root. So here meter will get cancelled, here cancel, you will get 2. So it will be equal to root of meter square by second square, so which means meter per second. So Vg equal to meter per second. Now you see Vg equal to meter per second, which is the velocity of, which is the dimension of speed. Okay, dimension of speed. Now suppose if the questions were, in the question options were lambda power 1 by 2, b lambda power 3 by 2, c lambda power minus 1 by 2, d lambda power minus 3 by 2. For none of the options other than c, you would get Vg's dimension as meter per second. If you want, you can try it and see. For none of the options, if you put lambda equal to lambda is dimension as 1 by 2, you check it here. Lambda is 1 by 2, root lambda into t. So root of lambda t. Lambda is meter, t is dimension of t is meter cube per second square, right? Under root. It will be equal to meter power 4 by s square. It will be equal to meter square per second. This is not the dimension of velocity. Okay, so option A is wrong. Similarly, B and D also will be proven wrong. So this lambda has to be minus 1 by 2. Okay, here find Vg. Vg means we need Vg is equal to minus lambda square d nu by d lambda. So this is what we require, d nu by d lambda. So now the first thing that you can do is you can just square on both sides. Squaring lambda square is equal to c square divided by nu square minus nu naught square. Then you can just rearrange, bring this there. So nu square minus nu naught square equal to c square divided by lambda square. Nu square minus nu naught square equal to c square divided by lambda square. And what is nu square? Nu square will be equal to c square by lambda square plus nu naught squared. Okay, leave this here. Now you can differentiate 2 nu d nu, differentiation of nu square is equal to c square times, this is lambda, so this is minus 2 divided by lambda cube minus 2 lambda cube d lambda, and this nu naught is a constant that you can leave. Okay, now you need d nu by d lambda, d nu by d lambda. It's okay. So d nu by d lambda is equal to minus 2 c square divided by lambda cube into 1 by 2 nu. Two gets cancelled. So that is c square divided minus c square divided by nu times lambda cube. Okay, fine. So now let us write Vg. Vg is equal to minus lambda square. Now what is d nu by d lambda? Minus c square divided by nu lambda cube. Lambda square, lambda get cancelled. Minus and minus get cancelled. Vg is equal to c square divided by nu lambda. Okay. Now when you say group and phase velocity, now these phonons, what are phonons? Phonons are now we say photons, right? Photons are quanta of light. Now phonons are quanta of vibrations, quanta of not general vibration, it is lattice vibrations. It require a medium. Most importantly, these things they can ask you in interviews. Okay. Now when you say this phonons vibrations and the motion of the phonons, it's nothing but we talk about the group. In group, what is their velocity? As you know, it's given by d omega by dk, or another formula is dE by dP, energy and momentum, and this is also you can write it as 1 by h cross dE by dk. H cross k is nothing but p. Okay. Now here comes the concept that for small vibrations, for small amplitude vibrations, small amplitude vibrations, the potential is considered to be as what is a second order. Up to second order there is significant. Second order, this is significance. Thereby yesterday we have learned about series. Up to what order it is significant, it is depending on the type of vibrations or type of the potential. So here it is significant up to the second order. Now for example, we have seen yesterday in the class what is sin theta. Sin theta equal to or sin x is equal to, we have written it as x minus x cube by 3 factorial, something like that. So here we can write theta minus theta cube by 3 factorial plus theta to the power 5 by 5 factorial. Then again alternate plus and minus will come. So theta to the power 7 by 7 factorial. Now this goes on, right? Now here what happens, in the small amplitude only the first two terms are important. So this is called harmonics. Harmonics in the vibration, these are called harmonics, okay, or second order vibrations. So this is called third order, this is fourth order, but these are very insignificant quantities. Okay, now because this is theta is very small amplitude, this theta represent the amplitude. Okay, yeah, so I can write sin theta as theta, because here the second term is missing, is 0. So you need not go after this theta cube by 3 factorial, you need not write. So for small theta, small angle theta, sin theta can be written as theta, and for cos theta, what was the formula? That is 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial minus theta to the power 6 by 6 factorial, etc. Now here as I said, it is significant to second order. Which is the order? This is the 0th order. This is the principal harmonics, 0th order. This, and here you have theta to the power 1, which is the primary first order. This is the second order. So up to here second order it is important. So we will write cos theta as approximately equal to 1 minus theta square divided by 2 factorial. So whenever we are talking about small amplitude, you can refer sin theta as theta and cos theta as 1 minus theta square by 2 factorial. Omega square is equal to omega naught square into 1 minus cos Ka. So cos theta can be written as 1 minus theta square by 2 factorial, because theta is small. Okay, now so omega square is equal to omega naught square into 1 minus cos k is 1 minus k square a square divided by 2 factorial, 2 brackets. So after that omega naught square into 1 minus minus, that becomes 0, so minus of minus plus k square a square divided by 2, because 2 factorial is 2. Now this is omega square. You can write omega is equal to omega naught into Ka by root 2. Now once you have omega, you can write Vp, which is equal to omega by k, that's equal to omega naught Ka divided by root 2. Okay, k get cancelled, so omega naught a by root 2. Now Vg is equal to d omega by dk, that's equal to k doesn't exist, so omega naught a by root 2. So Vg equal to Vp. Now this is a non-dispersive medium, so you should get the inference from your result. Non-dispersive medium. Think about the situations and understand. That means this particle is moving in a non-dispersive medium. You cannot see different waves. You see only one particular wave. Yeah. Just like the previous question, we can write cos theta is equal to 1 minus theta square divided by 2 factorial. Now here omega square is equal to omega naught squared into 3 minus, so cos ka is nothing but 1 minus kx square a square divided by 2 minus 1 minus ky squared a squared divided by 2 minus 1 minus kz square a square divided by 2. Now all that done. So that's equal to omega naught square into 3 minus, this is minus 1 if I take outside, this is again minus 1 if I take outside, here again minus 1 if I take outside, then minus of minus plus, so kx square a square divided by 2 plus this is again minus into minus plus, so ky square a square divided by 2, again this minus jumps here, plus kz square a square divided by 2. So 3 minus 1 minus 1 minus 1 all goes, so that will be equal to omega naught square into, I can write a square by 2 as common, a square by 2 into kx square plus ky square plus kz square. Now if I write the vector k as kx I cap plus ky j cap plus kz k cap, then magnitude of the vector k square I can write it as kx square plus ky square plus kz square, because that is nothing but k dot k. So this quantity becomes omega naught square into a square by 2 into k squared. Now we need Vg or Vp is equal to omega by k. So this is omega squared, then omega I can write it as omega naught a k by root 2. So Vp is equal to omega by k, that is equal to omega naught a by root 2, and Vg is equal to d omega by dk, that's equal to again omega naught a by root 2. So since Vg equal to Vp, this is again non-dispersive medium. This is another CSIR problem for diatomic lattice dispersion relation to acoustic branch. So this is, how do you understand this is acoustic branch? Here you have a minus sign from the first term to the second term. There are two terms here. The second term is negative, so that's why it is an acoustic branch. If it is plus, it would have been an optical branch. Now the question is to find group and phase velocity for large wavelength limit.